Okay, hello everyone. My name is Michał Dyrda, and today I will take you to the journey through our tools of the trade. I already introduced myself a little bit during the introduction video, but I would like to add that I have more than 11 years of the experience working as a data scientist, first in science, then for many years in the banking, and at the moment the Philip Morris International. From the educational point of view, I have got PhD in astrophysics. I'm still a cosmology fan, and what I do in my free time, it's a long distance runs. So a few words about Philip Morris International. So at the moment, we are undergoing kind of a digital transformation from something like old-fashioned retail company towards modern business where the data are the factors which are driven the decision makers on every day. And what I observed that, and also discussed with many professionals, that in the corporate world there is a problem that we need to fast deliver of reproducible models to the production. We know that data scientists have the capability to convert the data into the values, and this capability is highly dependent on what is the infrastructure, the data-related infrastructure, and how mature it is in the company. I could rephrase this challenge in other words, saying why most machine learning models never make into the production. But before that, let's think about what is not only the machine learning model, but what is a data product. So we can say that it's a software system which has a machine learning / AI component inside, and it's a part of a large business decision system. More formally, we can say that it's something which takes the data as an input, inside, and produce data as an output. Additionally, such a data product should be first of all, we should be available. It should be available for the updates, periodical updates with the new data, maybe new models, and so on. But also, it should be kind of responsive in the terms that once we are building a recommendation system on the web page, the recommendation must be provided to the users immediately. They don't want to wait for many long times. So it brings me to my first comment. So in the best case, the outcome of a data scientist job is the artifact which is meant not for humans, but rather for the machine consumer. We are all data scientists, but we are also programmers, computer scientists, so we prefer to have some sort of algorithm APIs than the PPT reports. And something which is integrated in the large business system and fundamentally changes the current business decision. So now we know everything about the data product, so let's start to shipping towards production. But before that, I would like to also mention that there's there is in many big companies, there is kind of something which is called culture conflict, because we divide ourselves into data scientists, which should do the modeling, data engineers, put models into production, build pipelines, and so on. There are also guys who are taking care about the platform, and this is tendency to go into the silos. Everybody is doing whatever is their job, and it's like throwing the ball over the fence on the hot potato from one hand to another. You're probably aware of these famous statements like, it works on my computer, here is my Jupyter notebook, please industrialize it. So this sometimes produce this vicious circle of the sadness, and people got frustrated. Before I will jump deeper into my presentation, let me introduce our data science team. We are part of Enterprise Analytics and Data Group. At the moment, in our company works 30 plus data scientists, basically in 3 locations: Amsterdam, Lausanne, and Krakow. In terms of educational, around 30% are PhDs, rest are master degrees. We are quite experienced people, a little more than 7 years in terms of professional experience in data science, but we are still very young in our company. We have different expertise from machine learning, big data engineering stuff. Also, the guys who are brilliant storytellers are in our teams. And most of us have different Scrum certificates. Probably most of us have professional Scrum developers, but for example, myself, I'm also a professional Scrum master. So we have like 3 types of the principles which are try to follow on the daily basis. First of all, just to protect sensitive data. Do not please prevent data leakage, and once GDPR should be in place, please make it fully compliant. Second one is avoid restricted open source libraries. We of course want to respect intellectual properties of any authors, but we need to also protect ourselves. And we are trying to minimize time to market, so we are trying to produce industrialization ready code. So in the beginning, how it was started, I will take you in the journey to the past. So 2012, 7 years ago, in October, these 2 gentlemen published a famous paper in Harvard Business Review that the data scientist is the sexiest job of the 21st century. Since it was Harvard Business Review, managers asked themselves, oh, is it really a truth? So let's do something with that. And our journey begins. The data scientist. You see that after publishing this paper, there was huge hype, and still we have increasing trend in terms of demand for the data scientist. But there were not so many data scientists at that time on the market, so there were different companies, open online massive courses available, and you could do your master in data science in 1 month. But of course, nowadays the situation is even easier. You need like 20 lines of your code if you are using Python and scikit-learn to build a random forest model. And AutoML is just around the corner, so any day things are getting simpler and simpler. But we as a data scientist, we should aspire to be somebody better, not just that one who knows better programming than a statistician. So basically, what is the perception? So I think that whenever I talk to young people who are starting their career, the perception is that what I will be doing, so 50% of my time I will spend on machine learning code. And there is something else, but maybe somebody else will do it. I don't know. So, but then the reality comes in place. So here is our machine learning code, and here is other things. So many people who are self-taught data scientists, they probably would like to work, as in many examples, with flat files, so they don't know how to query, how to scrap the data, and stuff like that. So they need to learn. Of course, they know something about data collection, as I said, flat files, feature extraction, maybe even something about the data verification. So before you are starting doing your first data product, I will quote a Google rule of machine learning number 1. Don't be afraid to launch a product without machine learning. The data product is, of course, a data science effort, and this is a tiny piece of the big software. And we need to know that this machine learning part cannot work with this software. But this software can work without the machine learning model. The simple heuristic can do sometimes a good job, and it was doing for many years. So then, of course, came the machine learning as a service. But that's okay, everything is all right, but I would like to mention Google rule of machine learning number 4. Keep the first model simple and get the infrastructure right. So let's see what we have in terms of the infrastructure. So we can divide existing solution into 2 groups, and basically based on how easy it is to control them and what kind of administration, DevOps maintenance we should pay for those systems. So here we have a simple Hadoop platforms, and here we have a well-known infrastructure at cloud and machine learning as a services. But we at PMI we had so we were discussing which approach we should use it, but we decided that we'll build something in between. It was mainly driven by the fact that in our company we have more than 2,000 different IT systems. Most of them they are producing the data. So if we want to do the data science at the corporate scale, we need to get the data from the systems. So that's our vision. We have different data sources from different IT systems. We have different factories, so we have also IoT and streaming data, and we built our platform. Here is kind of a conceptual model when we do our data science job, and we will produce many different outputs like data products, BI tools, and so on. But today I will focus only on the data products. So here is a vision. Now let's create our workflow. So we wanted to have something which would be, first of all, flexible. So we have as I said, we have different use cases from manufacturing to finance, supply chains and stuff like that. So we need something which will be flexible and easy to use for different use cases. Inspection ready. So whenever, be transparent, be ready for IT audit at any time. Easy to use. This is simple. Any kind of data scientists / developers, they love to use. They love to use different things, test different solution, experiment. So let them do it. And reproducible. It's simple. Anytime you need to repeat your results as you will be asked. It cannot be like that it works on my laptop, but why it doesn't work on your or in production, I don't know. I will come back to the reproducibility later during my talk. So we have a vision, so let's connect the dots and let's do our architecture. So first of all, we are using containerized, I would call it data science. So in something which we call data science labs, there is a Docker container, and in this Docker container, every data scientist has flexibility to install their favorite tools. We are basically using Python, but there are also people who are using R, so they have this possibility. They can maintain, and creating those containers is very easy. Each of the container has a possibility to read data from the different sources, for example, from any kind of Hadoop, Hive, and other databases. So this is the flexibility. Now, inspection ready. So anytime you create your code, you can store it in the Bitbucket. It's an Atlassian version of the Git, and all things like such artifacts like Docker containers are stored in JFrog Artifactory, which is scanned by the tool called Black Duck, which allows you to check of any kind of malicious things that you can think about that. I will come back to JFrog Artifactory later as well. So also reproducibility. If you have Docker, you can easily reproduce this Docker on different machines, on different labs, and code from the Bitbucket. Easy to use. As I said, people love to use different things. They like to build the web application based on Dash, APIs based on Flask. They can automatize everything via Jenkins and and Airflow, and we are also using Kibana for the monitoring. So we have the architecture, so let's come with the best practices. So we created our best practices and we divided them into 8, I would say, buckets. And today I will focus on those 6 ones. So first of all, for the reproducibility, the Docker containers. So why we are decided to use the Docker containers? As I said, freedom. You can install anything what you want, but be careful with the licenses inside your container. Easy of installation. It's something like writing a very simple kind of a bash script to create a Docker container. Reproducibility. If you do something wrong, you can destroy your container and build another one in a few minutes later. Isolation. As I said, it's isolated, so whatever you do in the container, you are not screwing up the whole platform, the whole system. And speed. It's quite fast, and I think it's well-known thing. So at the moment, we have a defined couple of templates for the Docker containers, like a base images for Docker containers. For example, if you want to have if you think that your data set will be bigger than 100 gigabytes, then please use that one with the Spark. Okay, so for organization and reproducibility as well, project templates. Before I will go to the project templates, let's think how the process, data science process, looks like. It's a well-known so-called awesome process. You can find it somewhere in the internet, for example, under this link. But it really reflects what we are doing on the daily basis. So first of all, we need to collect the data. Yes. So we need to obtain, either connect to database, download from internet, whatever. We need to obtain. Then what we do, we scrap. So detecting outliers, missing data. Although we are doing kind of aggregation, it really depends on the use case. Then the really, I would say, core of the data science job is coming. So we start to explore. We are building some simple statistics. We are doing feature engineering. And then the cream of the cream, so the modeling. We have learning algorithms. We can do hyperparameter optimization. And then what is in the end, we are industrialize our effort in terms of different reports, dashboard, API, whatever. So in order to speed up and follow this, I would say, natural process, we provide a cookie cutter. So the winter holiday is coming. Everybody, or mostly probably everybody, is producing gingerbread. So what is the cookie cutter in our case? It's a template. We store the template in the Git, and everybody just starting the project can clone this template. And as you can see, this template is reflecting the awesome process. First of all, what is important is the data. We store the raw data in the data raw folder, and raw data is immutable, so it means that you mustn't touch it by the hand. So no hand changes to raw data are allowed. So once you scrap, you explore, you put your data into interim, and finally, when you have your data ready for the final modeling, you put into the pre-process. Also the notebooks, Jupyter notebooks, they are also following awesome process. And once you are happy with your code, you can refactor your code and put into SRC folders, build your own Python packages. More or less, you have a Docker definition, you have a Jenkins for optimization. So here comes my remark on the reproducibility. So actually, in ideal world, any data scientist, but of course, you need to take sometimes a use case specification. So in the real world, everyone from the team should be able to reproduce your results based on three things: data raw stored in a raw folder, your Docker file, and code in SRC. That's the reproducibility. Okay, CI/CD. This hard part, but I will start with something relaxing. This is well-known quotation. It is not the strongest of the species to survive, nor the most intelligent, but the one most responsive to the change. This is basically describes this quotation from Darwin that describes you CI/CD practice on the everyday. But let's go to the more formal things. So first of all, continuous integration. So whenever you are producing your code, you are doing your exploration in the Jupyter notebooks, but then you are fine. You are producing function, maybe something bigger. Whenever you do something which has a kind of a which is a logical closed system, just merge your code to the master branch. So the more frequent you merge, the more production ready your code should be. But of course, this merging is not so trivial. The code should be, of course, reviewed by another data scientist. So whenever ready, merge. Then continuous delivery. This is very simple. So make sure that your code is always production ready. Whenever you will finish your sprint, your iteration, your manager, product owner says, yeah, I want this. You can just click few buttons and you can go to production. And continuous deployment. This is what we are expecting and what we are doing on the daily basis, basically with all our mobile devices, our computer. Whenever something is ready, just use it. Update the app and use it. So that's the CI/CD process and how it looks like in our case. So basically, artifacts which are produced by data scientists, model prediction, visualization, web application, whatever, are part of a software release cycle. We define that 3 stages of development. Okay, there is a phase, we could call it phase 0. When you meet with the business, you discuss what are their needs. You can do some feasibility studies. If, for example, if you need to predict, I don't know, your income, then you need to check, is the income available in the historical data? So basic checks, whatever you start this phase. Then the exploration phase began. So the alpha phase, you are doing the exploration and kind of a feasibility studies, and you are showing that you can bring the value. Then, and we strive, of course, to move fast from alpha to beta to demonstrate the value to the business. So then the automatization part starts. You should try to automatize as much as possible at that scale, at that stage. Of course, you can do. You can define SLAs, you can make estimates for the industrialization, you can test the scalability. And then there is the industrialization phase. Whenever you are ready, you can basically go for the industrialization. Script and coding standards. As I said, we are refactoring our code. I'm a big fan of Jupyter notebooks, but there are some buts. Of course, they are super cool for exploratory part and kind of a reports. I know even people who are doing very nice presentation in the Jupyter notebook to the business audience, but there are some drawbacks. First of all, the version control. It's really hard, and you cannot really use the full availability given you by Git if you are using Jupyter notebooks for your version control, and there is no refactoring code. But if you, so as I said, if you are happy, you do your favorite model, you do the function, you can just refactor it, but you can use it also in your Jupyter notebook, as I demonstrated here in this symbolic way. So whenever you want to use evaluation.py or domain.py, you can use it. Of course, as we are we are practicing this on a daily basis, but of course there are some pain points, because if you are starting, this is a kind of an iceberg problem, because if you are starting your project, I think that your production ready code amount will be minimal. Maybe after first iteration, first print, maybe none. But if you won't do it, you are doing something which is called in software development technical debt, because then you are end up with the fancy solution in the Jupyter notebook or any kind of the visualization, and then you have a problem because you need to refactor everything, rebuild everything, and automatize everything, which may not be easy. So as you see, you are doing at the beginning many exploratory code, not many refactor to the final solution. But if you approach the stage and your business manager says, yeah, go for it, let's go live, you can do it with few clicks. Coding standards. This is something I think most of you can easily, and you are following also on your daily basis. We are trying to produce code which fulfills these 4 points. First of all, it is readable. Readable in that sense that we try to use such languages. Most of us are using Python, some of us are using R, that your colleagues can understand. First of all, because in order to merge to master branch, you need to do it via pull request. So somebody else, you need to find somebody who will review your code. Reusable, as I said, this refactoring is not only meant for producing a nice code production ready, but if you do some kind of a Python package, then it can be used by your colleagues in other project. Tested, as I said, try to verify that everything is working correctly, and reproducibility I've already mentioned. We try to follow kind of style guides. At the moment, PEP 8, there are, as you probably know, useful tools which you can check your code. You can use different also things, editors, like, for example, open source, as many, either open source or some licensed product to do it. And we encourage everybody to write the docstring and kind of hints how to use your function. And once your code is reviewed, go and merge to the master branch. This will allow you for easy deployments. So what are the steps for the deployment? You have your model, you have everything prepared, you have your data product, it's warped inside the Docker container. It really doesn't matter what is inside the Docker container. Is it a static visualization, web app, whatsoever? You publish Docker image to the Artifactory. Then there is a template, of course, for that. You can create a configuration file and push it to repo. Use Jenkins, which pickups and runs the deployment. And voila, your application is ready for and to be accessed by your business users. Kibana and Airflow. We are using, as I said, Kibana for monitoring. You see one of the examples which we used during beta phase. We give it to some test users, so kind of a user acceptance test. And we put some metrics, as you can see, how many times they log into the app, how many times they run the model. And there was also some functionality which our product owner insists that they can download the results in the form of CSV file. We said maybe it's maybe they don't need it. We provide some nice visualization, but he insists. So we said, okay, let's put the monitoring on that, and we will see how many times they use it. I would say not so many. We are also monitoring some warnings. As I said, it's a beta phase, so we are looking at these warnings after they appear on the dashboard. Airflow, whenever you build your data product pipeline, we are using an Airflow. You can integrate different jobs from, for example, data engineers building your automatized pipeline in Scala. Then you can put your piece of the software into it. Basically, it works like more or less a scheduler. I would say it computes so-called this direct acyclic graph. So what modules, what code should be run after one after another, but it has a very nice functionality comparing to very simple one like Chrome, for example, that if something it fails, it stop the whole pipeline. This is very nice functionality, and you can check it and monitor it. What else we are doing in data science? So we have a best practice ambassador network. There are a few people from our data science group which are doing basically we are supporting a technical assessment of the tools and methods which should be used by our colleagues. We are doing in-house training. We are also providing coaching services, facilitating retrospective for other teams. We are participating in meetups and conferences, and we are also doing kind of a technology scouting. So at the moment we are looking at MLflow, which will allows you for the monitoring your machine learning experiments. Of course, the AutoML is around the corner. We are also checking some AutoML packages. Also kind of Dask, for example, for parallel Python computation. We promote and continuous learning, so we encourage our colleagues to progress along their career path. We are providing them different opportunities, for example, conference attendance. Everybody have Safari online book subscription. They can take any kind of massive open online courses. And we are also providing in-house training. This brings me to my conclusion. So first of all, if you want to engineer a smart system with the AI machine learning core, it's not so easy. It requires that your team have a lot of different capabilities and individuals who can work together in order to create a final result. I think what is very special for the data scientists is they can work hand by hand with business and technical people. But we need to say that we are part of something bigger, and we need to learn and master our stuff on a daily basis. So I hope that all things which are presented makes some kind of guidelines for you. And thank you very much for your attention.